Okay, so this talk is actually an introduction to JaamSim Pro, and it'll lead up to a LNG type shipping model as this final example. So we've talked quite a bit about JaamSim Pro in this conference so far, but most people in this conference will have never used it. It's because it's specialized for transportation and supply chain type problems. But I think it would be useful to go through it and see how JaamSim Pro works, because there's some very interesting things in it that are unique to JaamSim Pro. And I also just like to reiterate that that the JaamSim Pro adds these libraries of objects for transportation, material flow, and mapping, but everything else in it is identical to the free open source version. So if you don't need these features, you're getting the best version of JaamSim. You don't need the Pro version to get a better input editor or something. You've already got the best stuff. So the first library of objects that I'll talk about is the transportation library, and this is the one that does vehicle motion. Vehicles can be trucks, trains, ships, barges, you name it, anything that moves in space. And there are two, in addition to vehicle, there are two subclasses: container vehicle and cargo vehicle. Container vehicle is a bit like an entity container in the open source JaamSim, except it's a vehicle that can carry other entities in the same way that an entity container does. And it's loaded and unloaded by the usual objects from the process flow library: pack, unpack, add to, and remove from. The cargo vehicle is a vehicle that carries bulk material, such as crude oil, LNG, iron ore, and so on. And it's unloaded and unloaded by objects in the material flow library. And we'll talk about that just in a minute. So how do vehicles work? Vehicles move between transport origin and transport destination objects along a path defined by links and nodes, so the transport link and transport node objects. In addition to the transport node, there are subclasses, delay node, seize node, release node, that work in the same sort of way that the entity delay, seize, release, and assign nodes work in the process flow library. So this allows you for vehicles to wait until a resource is seized, or they're able to receive a resource before proceeding on further. The vehicles in JaamSim Pro move realistically. They accelerate and just decelerate smoothly, so you don't see a vehicle suddenly move off like it's shot from a cannon at its maximum speed. It accelerates smoothly at a specified acceleration rate up till its maximum speed, and then carries on at that speed. If it hits any speed limits for sections of the road where it has to reduce speed, it will reduce speed and ahead of that new section, so that when it hits that section, it's going at its correct speed limit. Vehicles automatically avoid collisions and deadlocks of the opposing vehicles. So you'll never have the situation where two vehicles will enter a section and run into each other and unable to go forward, to ever go forward, which is what a deadlock is. And the vehicles will choose the best path to the most appropriate destination. So meaning if you've got a vehicle that's carrying a particular material, and it will look at the destinations that are suitable for that material and with various other rules that you've specified, and then find the best path to that destination. So there are alternate paths. It'll choose the one that's available and that has the best characteristics. And lastly, vehicle movements are controlled by a transport manager object. So this object coordinates all the activities between vehicles and it identifies what links and nodes the vehicle can travel over. So to try and put this into context, let's look at the simplest possible example you could have of a vehicle. Uh, and this little model is one of the ones that's provided as an example model in JaamSim Pro through the help examples keys. Uh, so in this model, we have a single vehicle, vehicle one, and it travels between transport origin one to transport destination one over three links. And when it gets to the destination, it's sent to the queue. So it's very simple. The vehicle has no length. It accelerates and decelerates instantaneously, and it's in this little example the it's traveling at 2 meters per second. So which gives it a total travel time of 12 seconds. And I think just to illustrate this, I'll launch JaamSim Pro and we'll just watch that happen. Where oh the so here it is. Here's the same example. I'll just launch it and and when I run it, so here's vehicle one over here. And when I launch it, it goes to transportation origin one and moves along the path nice and smoothly. It gets to the end in a second and goes to the queue. So nothing very exciting is happening. Uh, but what is exciting is just, first of all, how simple it is to build this model. It only has half a dozen objects in it and not that many inputs. And we've managed to do quite a nice little vehicle model. Um, One thing you would note in the software when you're using it is there's no need to tell the vehicle, oh, I want you to move forward in steps of 2 millimeters. You don't have to discretize the motion. JaamSim Pro is the vehicle motion is entirely event based. Uh, um, and this is unique to JaamSim Pro. Other software packages that have vehicle motion in it will specify your a step size, and it'll step through that thing laboriously from origin to destination, which is extremely time consuming. It's fine for simple models, but you build a very complicated model like the ones we've been, like Dan, like Justin was just showing us now, and the software will run very, very slowly. Uh, where are we here? So going back to the PowerPoint here. So what I was saying is it's entirely event based. So that vehicle only executed five events. The one event to get the vehicle started. 5 seconds later, the vehicle has traveled through the first link and arrives at the second one. 7 seconds at 7 seconds, 2 seconds later, it arrives at the end of the second link, and 5 seconds after that, arrives at the end of the third link. And at that point, it arrives at the destination and is sent to the queue. So very little computational work gets done to model that vehicle. And when you're running when you're running in real time mode, you see it all moving very nicely and smoothly from origin to destination. When you run it as fast as possible and unclick the real time button, it'll now just execute five events, and it'll be gone before before you've even noticed it. This makes a huge difference in complicated models of how efficiently JaamSim Pro executes. So that's a quick introduction to the transportation library. The material flow library is similar in some ways in design. It defines a material which is a bulk material, which could be a liquid or solid bulk. So it could be crude oil, LNG, iron ore, coal, you name it. And the materials can be held in a mat flow storage object, which represents a tank or a stockpile. And you also have source and sink objects, which represent a storage essentially with infinite contents or sink with infinite space. Um, the material flows move from a source to a destination defined by links and nodes, similar to the transportation palette. And the flows are initiated by various types of objects. The simplest one is the mat flow system. Uh, and it represents a flow of a single material flow from a single origin to a single destination. A splitter takes flow from one origin and divides it to two destinations by fixed ratio. And you can also convert the product the material to different materials to those two destinations. And a combiner does the opposite. It takes material from multiple origins and combines it to a single destination, again with optional material conversion. So just like the trains, vehicles, the materials flow smoothly from source to destination. They obey the flow rates for the path and the maximum flow rate for the mat flow system. They allow for transit times for along the links in the path, and they also can be restricted on splitting or combining flows along their paths. So there's sometimes you'll have objects where two different flows could use that same link, but they can only one of them can use it at a time. So you can restrict combining along a path. And lastly, the material flows conserve mass exactly. So let's look at a simple material flow example. So here we've got material. We've got 100 kilograms of material in storage one. It's flowing over three links to a destination storage, mat flow storage two, and it only has 50 capacity for 50 kilograms. The flow rate is 8 kilograms per second, and the total travel time is 5 seconds over the three links. So what happens is the flow starts. You see the start of the flow work its way through the links, reaching the storage two, and then storage two fills up. Before storage two is full, but there's enough material en route to fill it, then the flow from storage one stops, and you see the system empty out with 50 kilograms in the full destination. So again, let's take a look at that in action. So we see the material flow, and now there's now enough material in flight to fill the destination, and we get there. So again, very simple. And again, this is all done entirely with event code. In other software, you have to specify what increment of material do you want to move in. So you're moving, in this case, you're moving 50 kilograms of material. Maybe you want to move it in 1 gram increment or 1 gram increments or 1 kilogram increments. So now you've got 50 steps to move the material from the source to the destination and along each of those links. So it's very time consuming. Whereas in JaamSim Pro, there are only just 4 events. There's an event to start the flow. There's an event 5 seconds later when the first part of the flow arrives at the destination. A little bit later, there's enough material in flight that the flow out of the source stops because there's enough material in flight to fill the destination. And then 5 seconds later, the last of that flow arrives at the destination, which is now full. And you can see those events in the event viewer below. So again, this is very efficient, and this event based is what makes JaamSim Pro so fast, and allows us to build the very elaborate bulk terminal and transportation shipping models that are being built with JaamSim Pro. So lastly, I'll show you, we've seen the material flow and the transportation working separately. And this last example is an LNG shipping system where these principles are combined. So there are many more objects here now. We've got two cargo vehicles that you can see in the screen in the shape of ships that are moving between a loading terminal over here to two destination terminals over here. And the lines are the links connecting them. One interesting, these areas where the ship is being loaded and unloaded are the mat flow stations. And those act as an interface between the transportation system objects, the ships, and the material flow system. And those you can think of those as being berths in this case, and those are resources. So you actually seize the mat flow station before you arrive and release it when you leave, and that's to prevent another ship from coming along and trying to enter your berth while you're still there. A very necessary point. It also ensures now that you have utilization statistics for the mat flow station, which is what in a shipping model is one of the things you look at. What's the utilization of my berths? So the last thing in JaamSim Pro are some map objects, and we actually haven't made much use of this yet, but it's actually a very cool feature in JaamSim Pro. It only has two objects in it. It has a map region, which is a region which has a map for its background, and you have map location, which is a way of specifying a place in the region with a specific latitude and longitude. And that's necessary because regions still work in distance units of meters or kilometers, but we're now in a Mercator map projection where there are no distances in meters and kilometers, only latitude and longitude. So you need a way of converting from one to the other, and the map location does that. So here's an example of a map in JaamSim Pro. These two windows show the Vancouver area at various levels of enlargement. The one on the left shows a very detailed view of the city with a map location object located at Vancouver Airport, YVR, located down here. And the second view window shows a zoomed out view of that, showing a good part of the province in Washington State. What's interesting here is that these two views can exist are in the same model at the same time. So the map tiles that you display are determined on the level of zoom in each individual window, each individual view. So you can build a model that shows, for example, a very large scale view of a map showing ships moving from one place to another. And then you have two other windows showing zoomed in portions of the loading terminal and discharge terminal each end. And so when ships and those can all appear at the same time to produce quite a pleasing display. And I think that's unique to JaamSim Pro. I think with the other software packages, you can show one map at a time. The maps that are being displayed are in this example are from OpenStreetMap, and that's probably the default for any mapping. But you can hook it up to a corporate map server. For example, you don't have to use OpenStreetMap. So you can have custom maps for your company that display your maps the way you want to and have greater levels of detail if necessary, and higher performance than you would get from OpenStreetMap. So just in conclusion, the material flows and vehicle movements in JaamSim Pro are very fast. They avoid a lot of problems that the other discrete event packages have with their packages. There's no need to discretize the processes, either vehicle motion or material flows, and consequently there are no accumulated round-off errors and slow execution speed associated with the discretization. Uh, the other thing that is unique to JaamSim Pro is that the material flows and vehicle motions are controlled automatically. You don't have to go and write code or create objects to control the material flows. That the materials flow start and stop with built-in logic that you just have to provide parameters for. With other software, things can move around, but you've got to have objects that tell them when to start and stop and what to do along the way, which is quite laborious when you start to get into complicated vehicle movement rules. The mass is conserved exactly in these models, and that the vehicles move with smooth acceleration deceleration, which really enhances if nothing else, it really enhances the visuals of a model. It's very disconcerting when you see a truck at a loading station and it finishes loading, and then suddenly it's shot out of a cannon and at its full speed down the path. Not to mention unrealistic for things that have slow accelerations like trucks and trains. So that's all for JaamSim Pro, and hopefully we've caught up to our schedule a little more now. Thank you.
Thank you very much, Harry. I'll take a little bit of time to just plug tomorrow. I'm going to be teaching a masterclass on building a pit to port model, and we'll be using these three libraries that Harry has mentioned. And so if you found Justin's presentation interesting on, moving iron ore out of a mine, or, LNG tankers, and you want to get in and learn a little bit, there is time to still sign up for that. And the class will be roughly at the same time as this conference. I think we've scheduled, it's probably several hours of work. So anyways, there are several questions here. I think Harry can, maybe read them and answer them how he wishes. I see some good questions.
So the first one I see is from Anthony Earl. Do the tools that city planners use to configure traffic lights, for example, to configure traffic lights, have better functionality than in JaamSim? It seems that their results are often not an improvement into traffic flow. That sounds like a commuter's lament. Actually, for traffic modeling, Harvey Harrison's the expert in that. That's what he does for his day job in consulting. But I can answer a little bit of that. Those are called micro simulations, where they look at individual vehicles at intersections and things. And of course, those models are specialized for working with that particular application, whereas JaamSim Pro is a general purpose tool. So I would say that for configuring traffic lights, that those tools are probably have better function than JaamSim. JaamSim has really been oriented more to shipping and truck fleets and rail networks and such, not individual traffic lights. That's not to say that you couldn't build an application for that in JaamSim Pro, but you would have to do some work to do it. Harvey, did you want to jump in on that about micro simulations? Maybe Harvey's had to go to work here. I'll go on to the next question. How does this story of continuous flow combine with the earlier statement of ticks as an underlying principle? So time is advanced we're keeping track of time in ticks, and in JaamSim, a tick is by default a nanosecond. So it's a very small tick. The the only impact on that is for the smooth movement is that when you're predicting the time that a vehicle is going to arrive at its destination for where its next event is going to happen, that time would be specified calculated in ticks. So 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 at most there's going to be a round off in the nanoseconds for that. This is different from when you're moving in small steps from your origin to your destination. So you're not moving in ticks, you're moving in meters. And and then there's quite is both in terms of time consuming for the software as well as potential for round off error, accumulated round off error it creeps in. Um, Mark has asked if there are only 4 discrete events in the simulation. Is the visualized code just maintaining intermediate state variables that are interpolated between the events based on the frame rate or the real-time factor? That's an excellent question. Yes, that's exactly what happens in JaamSim. The user interface is advancing time smoothly through the simulation, the simulation run, and when you're in real time mode, you're advancing time smoothly from that, and the events are firing at the appropriate time. But the graphics now are using the user interface time to determine where things should be. So the vehicle, even though there's no event at that time, the vehicle knows I've been traveling for 3 seconds, and I've been traveling at this rate. Therefore, I must be this position on the path. So that makes both the graphics very smooth and very pleasing, but without creating any increase in computational load when you're running the model outside of real-time mode, where you're just going from event to event. Tim Colville has asked, I was having an issue with Flow Manager and the tanks. I could not figure out how to start and stop a flow from mat flow storage once a tank filled 40% volume in the tank and would it would stop a flow from a mat flow storage. Once a mat flow storage filled 40% of the volume of the tank, it would start to flow. The inflow feed was greater than the outflow feed of the tank, but there was stoppage points in the inflow which allowed the tank to discharge with no inflow rate. Okay, I mean that the logic for flows in and out of a tank, simultaneous flows in and out of tank, and for starting and stopping flows, there are parameters to control all that. And if that is not enough, you can add expression thresholds that will add additional control on it. But I think that's probably something that Tim and I should discuss offline. I think it's a bit too complicated to talk about in the conference right now. So Tim, please send me an email or ask a question on the forum, and we'll dive into this question. And Shellswell has asked, acceleration and decelerations can have significant impacts in traffic dynamics. For the transportation library content, what happens with equipment speeds if the roadway segment is not long enough to accommodate the full acceleration and deceleration? Oh yeah, sure. Example, the equipment starts from a stop and begins to accelerate, but the link isn't long enough to reach the top speed. And the answer is yes, that is taken into account. In that case, the vehicle would accelerate smoothly till the point where it has to start decelerating again before it reaches full speed, and then it'll decelerate smoothly down to zero or down to whatever it needs at its destination. So that point is covered automatically. Jason asks, in regards to calculating fuel consumption, it seems to me this could be calculated using the model output files based on a time series of vehicle speeds and activities, as well as the vehicle's position. Yes, you could, with the additional information of knowing the grade and fuel consumption curves for the vehicle. I think, I mean, in principle, it's possible to do it, but I think it would probably be more work than you'd want to do more than once. So I think if there's been a demand for incorporating fuel consumption into JaamSim Pro, and it looks like there is, and that's something that is a feature that's needed, and I'll talk to the various people about how best to implement that.
Yeah, I was just gonna say we did something like this for one of our projects. Well, that it's actually on the Ausenco website, the CP Rail greenhouse gas emission study, where we were able to take the dynamics of the output files of the rail activities and speeds, and do a pretty good job of calculating carbon emissions. So.
Well, that's a very I didn't know that, Jason. That's a very cool application. That's with the TLS Senko's simulation package, which is based on JaamSim and similar.
Correct, but all we really needed there were the positions, and in that case, and it was an estimate. It was a pretty good estimate. We just needed the activities, the speeds, and then we also had the fuel curves. So it was all able to take the output files and do that calculation.
Yeah, no,
throwing it out there.
That is very cool.